All right, so let's explain how do we draw an irrational function. So for example, let's have the function that we want to draw is the square root of x minus 3 and plus 2. So the first thing that we have to notice is that what numbers are inside the square root and what numbers are outside the square root, or coefficients. Now, the number that is inside dictates whether the function is shifted towards the left or to the right. And the number that is outside the square root dictates if the function is shifted up or down. Specifically, if we have, for example, minus 3, the function is shifted towards the right. And if there is, for example, plus 3, the function is shifted towards the left, of course, by 3. So what do we do now? So the first thing is to write down where the function is shifted. Yeah, so if we were to draw the square root of x, this square root of x would be shifted 3 towards the right and 2 upwards. It's just a good understanding of where it shifts. With this knowledge, we will draw a coordinate table where essentially we just need 2 points. We need 2 points. Now, the first point is when we plug in the number 3. So how much it shifted. So the first number that we plug into the table is how much it shifted in the x-axis. So when we plug in 3, is 3 minus 3, which is 0, square root of 0, plus 2 is 2. Notice is that the 3, 2 is our first point. Now for the second point, I really recommend to plug in a number that we get a nice square root. So for example, what number can we plug in order to get the square root of 4? What number? Yeah? And that number is 7. So I will plug in 7. The square root of 7 minus 3 plus 2. And this equals to the square root of 4 plus 2. And that is equivalent of 2 plus 2, which is 4. So our second point for our graph is 7 and 4. Now, what do we do with this is that, of course, we draw a coordinate system. Now, I will not include the negative. I'll just include the positive, the first section, so x and y. Let me add the x's. So it's 1, 2, 3, 4, 5, 6, 7. Let me also label these points on my coordinate system. And then with a very similar step, which is very important, we have 1, 2, 3, 4. Now our first point we have is right here. So our x is 3 and y is 2. So this is our first point right here. And our second point is 7 and 4. 7 and 4 right here. Now it's extremely important to understand how the square root grows and the shape of this function. If we would, in fact, let's plug in one more number just to prove a point. So let's plug in a number in between. So for example, 5. And it will not be a nice number, and that's completely all right. So, for example, let's plug in the number 5. All right. Let's plug in the number 5. We get 5 minus 3 plus 2. Again, this will not be a nice number because of the square root of 2. And if you take out a calculator, the square root of 2 is approximately, and I say approximately, the square root of 2 plus 2 is approximately 3.4. Approximately, we can use these wavy lines, 3.4. So it is 5 is 3.4. Now, if you draw this function, it will slowly look something like this. So going here, here, and it would continue as such, yeah? Slowly increasing and slowing down. Really important point is we can check how this graph looks by, well, opening a browser, going to desmos.com into the open graphing calculator, and now simply by typing the square root of minus 3 plus 2. We can see that we have the correct points.